All right, on to the next vocabulary term. We're going to learn about electrolytes, okay? So electrolytes, the definition is compounds that conduct an electric current in aqueous solutions, okay? Think of electrolytes as things that cause electricity, okay? Electrolytes, electricity, that will help you remind you what it is, okay? Basically, an electrolyte are going to be from ionic compounds, and covalent compounds are not electrolytes. Okay, so let's sort of recap why ionic compounds will become an electrolyte. So ionic compounds do what we call ionize, okay, meaning they separate into positive and negative ions in water to produce charged particles that can carry an electric current, okay? So for instance, if you take NaOH or NaCl and you put it in water, they separate. So you have a positive sodium here and a negative hydroxide over here. Over here you have a positive sodium, and over here you have a negative chlorine. So when they separate, you have a bunch of pluses and minuses just hanging out. And when you have positive and negative charges, that is what causes electricity to run, okay? So if you go onto the bottom here, electrolytes will light up a light bulb, okay? Because you have a bunch of positive and negative charges here, positive and negative charges, when you have charges like this, that is what causes light bulbs to turn on, okay? You need charged particles to have electricity. And these charged substances will be called an electrolyte. So if we go back and talk about non-electrolytes do not conduct an electric current because they do not have positive and negative charges, okay? If you were to look at sugar and you put it in water, sugars don't separate, okay? Sugars don't separate, so they just are hanging out in big blobs like this. They are neutral, no positives, no negatives, and therefore they will not have any positive or negative charges, okay? So let's fill out this sentence here. Covalent compounds do not dissociate, meaning that they do not separate in water, and thus do not form charged particles and do not carry an electric current. Okay, so non-electrolytes will not light up a light bulb because there are no positives and negatives, no charged particles, so it is completely off. No electricity when you have sugar in water. Okay, so let's recap back here. Remember, inside water, right, you have H2O. Remember, you have oxygen that is partially negative and hydrogen that is partially positive. So when you have an ionic compound, ion, meaning they have positive and negatives, that water molecule will separate that positive, negative, and that's why they break apart like this, right? So think electrolyte, you will get a nice light bulb shining right here. Okay? But a non-electrolyte, you do not have any light. No light. Okay? So think of those keywords when you are trying to solve your electrolyte and non-electrolyte problems. Okay? So here, let's practice. Okay? here's a chart below where you are going to identify whether these compounds are going to produce an electrolyte or a non-electrolyte. Okay, so a couple of things to recap to help you with these problems. Remember the trick, I'm on CNN. I'm on CNN, okay? What does the I stand for? It's ionic. An ionic bond is when you have a metal with a non-metal, right? And then what does covalent bonds mean then? Covalent bonds, choose a different color here. Covalent is when you have a non-metal with a non-metal, okay? So when you think of ionic bonds, ionic is when you have positive and negatives. And when you have positives and negatives, then you have an electrolyte, because when you have charged particles, you will get light, electricity, okay? So let's recap on your periodic table here what your metals and nonmetals are. Okay, so remember that your nonmetals are, let's look here, going to be on this side of your staircase, plus hydrogen over there, okay? And then your metals are everything else here, okay? These are all metals, okay? So your staircase separates your metals from your non-metals. So look at the staircase, okay? Except hydrogen here, it is a non-metal, okay? So let's go back and identify these type of bonds. You have K and Cl, you have a potassium and a chlorine, so find them on your periodic table here. Potassium is here and chlorine is here. If you have a metal and a non-metal, then you know you have an ionic bond, right? So look at your little cheat sheet up here. I'm on CNN. If you have an ionic bond, you have positive and negative charges. Therefore, you are an electrolyte, okay? All right. You are going to try the rest of these, okay? A little side note here. Remember, if you have a polyatomic, you're automatically an ionic bond. You have ions. Okay, so I would take this moment right here and fill out the rest of the chart. And then, so pause. And then if you play, I will have all the answers just show up. All right, so here are all the answers, okay? For example, like this one right here, it's sugar. Carbon, hydrogen, and oxygen are all non-metals. So if you looky here, you have carbon, and then hydrogen's over here, and oxygen, they're all non-metals. So you know you have a covalent bond. Covalent bonds do not have charges, okay? So that's why it is a non-electrolyte, because it will not light up, okay? All right, so hopefully you got the rest of this chart right. So now let's look at how you will see this on your quiz and test. The question will ask, will a solution of CCl4, okay, carbon tetrachloride, conduct electric current? Justify your response. Okay, for us to answer this question, we first need to identify this compound here, carbon and chlorine. So let's find them over here. Carbon is here, chlorine is here. You have two non-metals. If you have two non-metals, then you know you have a non and a non. That means you have a covalent bond. A covalent bond has no charges. Therefore, it will not conduct an electrical current, okay? No charges, okay? What about Li2SO4, lithium sulfate. Will lithium sulfate conduct an electric current? Okay, a couple of things here. Lithium over here is a metal. When something has a metal, you automatically know it's going to be an ionic bond. It's also attached to a polyatomic sulfate, so you know that it is an ionic compound. So here you have a metal with a polyatomic. This is an ionic bond. Ionic, ion means they have charges, meaning they have a positive and negative, and therefore, yes, it will, ooh, that will looks sort of weird. Let me rewrite it. Will conduct an electrical current. All right? Okay, now let's talk about the vocabulary word concentration. Concentration is a measure of the amount of solute per given amount of solvent or solution. Okay, so if you can see here, it's measured in what we call molarity. It's capital M. So here, this is a concentrated solution, meaning there's a lot of solute in solvent, and here you see that it is a small concentration. It is a low concentration of solute per solvent. We're going to learn these words in more detail when we get to the math, but here you have a concentrated solution, and here you have what we call dilute solution. I'm sure you heard of that word before. Okay, but concentration is all about how much solute, for example, like salt, you have in water. Okay, so here are some more vocabulary words that we need to learn. A saturated solution means it contains the maximum amount of solute that will dissolve in a solvent at a given temperature. Meaning that if you put more solute than the maximum, it will not dissolve. It will just sink to the bottom. It's like when you add sugar to tea and you mixy, and there's still sugar at the bottom, that means you've already hit the maximum. It's saturated. When something is unsaturated, that means you can dissolve more and you didn't. So if you are dissolving the sugar in tea and all of it disappears, then it is probably unsaturated because you can put more sugar into that tea. Now, we're going to be reading solubility charts, okay? This is an example of a solubility chart right here. A solubility chart will show temperature versus the amount dissolved. Okay? The line on the graph will tell us the point of saturation at a specific temperature, because usually the hotter it is, you can dissolve more, okay? If it's on or above the line, we say that it is saturated, meaning you hit the maximum. If it's under the line, it is unsaturated, because that means you could dissolve more. Okay, so here is our solubility chart. Okay, a little zoomed in version here. So this line right here tells us the point of saturation. So we're going to be answering questions based off of this chart here. Okay, so for example, it says, question number 1, from point X to point Y, the potassium nitrate solution is going from blank to blank. Okay, so we're going to look at point X to point Y. All right, point X to point Y is here to there. Okay, so you're going to take a look. At point X, it is above the line, right? At point Y, it is on the line. And what did we say in our notes earlier? If it is on or above the line, it is saturated. So for us to answer this question, we are going from saturated to saturated. All right, let's look at the next one. From point Y to point Z, the potassium nitrate solution is going from blank to blank. All right, so if we go back here, point Y to point Z. Okay, there's that there. Point Y is, once again, on the line. Point Z, here's where the line is right here. It is under the line. So how are we going to answer this question? We are going from saturated, because it was on the line, to unsaturated, because it was under the line. Okay, so I did 2 examples here. I'm going to have you do the next 2 on your own. Okay, I'm going to show you another example of how to use the graph looking at these down here. So I'm going to do 2 of these examples. Okay, it says we're going to determine if the following is unsaturated or saturated using the graph. So the question is, at 40 degrees Celsius, 100 grams of potassium nitrate. Okay, so if we go back here, let me go ahead and erase all of this so we can start all over. Okay, so we want 40 degrees Celsius, so you have to find, here's temperature, 40 degrees is right here, and 100 grams is right here. So you're going to make a little point at 40 and 100, and you're going to ask yourself, is this on/above or is it under? It is above the line. Anything that is above the line, we say it is saturated. So you put sat for saturated. Okay, let's do another example, like number 2. So 55 degrees Celsius, 100 grams. So let's go back here. 55 is probably right here. Okay, and we're going to go up 100 grams, which is right here. This is on the line. If it's on the line, is it saturated or unsaturated? It is saturated. Okay, so if you draw a point that is under the line, then it is unsaturated. Okay, remember, if it's saturated, it is on or above the line. Okay, so you're going to do the rest for practice. All right, on to the next thing of how we can use our graph. All right, so here's a couple more ways that we can use our solubility chart here, solubility graph. Okay, so this is a totally different graph over here. So let's read this first sentence here. It says at 10 degrees Celsius, blank is the most soluble and blank is the least soluble. So here we have 3 different compounds. We have potassium nitrate, potassium chloride, and sodium chloride over here. So we want to know out of the 3, which one is the most soluble, meaning it can dissolve the most amount. Okay, so you're going to look at 10 degrees Celsius, which is right here, and you're going to go up to the very highest line you see. That's this one here. This line belongs to NaCl. So you're going to say that NaCl is the most soluble because it is the highest one here. I know it's a little hard to see, but this line right here belongs to NaCl. It wants to know the least soluble as well, so you want to find the line that is the lowest at 10 degrees, and the one that is lowest at 10 degrees is this one right here, and this line belongs to KNO3. So then the answer over here is KNO3. Okay, so you're going to do the same thing in these next 2 problems at 30 degrees and at 60 degrees. So here's 30 degrees to 60 degrees. Look to see which one's highest and which one's the lowest, okay? Now, this next portion right here is ones that we have done before, so you should know how to do it, but something to be careful about. It says at 90 degrees Celsius, 50 grams of KCl. So you have 3 different lines over here, so you are going to have to be careful as to which line belongs to who. Okay, if you get confused, then you'll be answering the wrong thing. So first you find 90 degrees, it's right here, and you find 50 degrees, okay? And that's this point right here. It's specifically talking about KCl, which is this this guy right here, so it's specifically talking about this line right here. Now, in according to this line, is it on, above, or under the line? It's under the line, so we call this unsaturated. Okay, one more example. Here you have 40 degrees Celsius, 50 grams of potassium nitrate. So you're going to find 40, and you want 50. So you're going to go up all the way here, and that's this point right here. This point right here, you got to compare the KNO3. So you want to look for this KNO3 line, which is this one right here. If you look closely, is this on, above, or under the line? It's under the line, so we call this unsaturated as well. Okay, so you're going to do the rest as practice. Okay, the last type of question you will see looks like this. Okay, where it says to use a graph to identify the salt or compound. So here it says you want 41 grams dissolved at 30 degrees Celsius. So when you're trying to identify, you are looking for the compound, okay, that has this description. So it's going to be on the line. On the line. So 41 grams, 30 degrees Celsius. So be careful, the temperature is down here. So we're at 30 degrees Celsius. We want 41 grams. So 41 grams is right here. Okay, so what line am I on? So I follow this line here. I'm talking about KNO3. So over here, I'm going to write it's potassium nitrate. Okay, let's do one more example. You have 50 grams here at 80 degrees Celsius. A very common mistake is a lot of people do 80 grams and 50 degrees Celsius, and that will not get you the right answer. So if you look at temperature, it's down here. We want 80 degrees Celsius, which is here, and you're going to go up to 50, which is right here. Remember, when you're identifying, it has to be on the line, okay? So what line is this on? This is on KCl. So you are going to write KCl here because this description was on the line of KCl, potassium chloride. You're going to do the rest as practice and get it checked by your teacher, all right? And then we will move on to precipitation reactions next.